If you're working with Google Cloud, there's one thing that stands between your critical data and, well, the entire internet. It's a system called IAM, Identity and Access Management. And let me tell you, mastering it isn't just for passing an exam, it's absolutely crucial for survival. So today, we're going to do a deep dive and decode Google Cloud IAM, from the very basics all the way to the pro-level strategies you'll be using every single day. So here's our game plan. We'll kick things off with the one simple question that drives all of IAM. Then we'll look at roles and how they've evolved. After that, we'll get into the policies that actually enforce the rules. We'll master the super important concept of service accounts, and then we'll wrap it all up with the key takeaways you're definitely going to want to remember. Okay, let's get right to it. When you boil it all down, every single security decision in Google Cloud comes down to answering this one simple question you see right here. Who can do what on which resource? It seems basic, I know, but getting this right is the foundation for absolutely everything else we're about to cover. So let's actually break that question down, right? The who is the identity. That could be a developer on your team, a whole group of engineers, or even an automated script. The what is the permission, the role we give them, like the ability to view a file or create a virtual machine. And the on which resource is the thing they're trying to access, that specific file, that specific VM. Every single API call in Google Cloud gets checked against this model, and if the answer isn't a clear yes, access is denied. Simple as that. Okay, so we've got the core idea. Now let's dig into the what part of that question, the roles. And this is where things get really interesting, and honestly, where a lot of people make some pretty dangerous mistakes. Understanding how roles have evolved is the key to not making them yourself. So way back in the day, when GCP was just getting started, things were simple. Maybe a little too simple. You basically had three main roles: owner, editor, and viewer. You can think of these as the sledgehammers of the permission world. Yeah, they were powerful and easy to understand, but as you're about to see, that brute force approach came with some massive security risks. And this slide just perfectly lays out the problem, doesn't it? Look at the editor role on the left. That is a sledgehammer. Let's say you just wanted someone to be able to upload files to a storage bucket. Well, giving them the editor role also lets them delete your production database and completely reconfigure your network. That is a huge, massive violation of the principle of least privilege. The modern way, on the right, is like a scalpel. It gives only the exact permission needed and nothing more. So, here's a huge tip, not just for your certification exams, but for your actual day job. If you see a basic role like editor as an option, it is almost certainly a trap. The right answer is pretty much always going to be the most specific, most granular role available. Thankfully, today our toolkit is way better. Google gives us hundreds of these predefined roles for all kinds of common jobs. And if, for some reason, none of those are exactly right, you can even create your own custom roles, literally picking and choosing the individual permissions you need. It gives you ultimate control and security. All right, so we have our who, our members, we have our what, the roles. Now, how do we actually connect them to our on which resource? Well, that's where IAM policies come in. They are the glue that holds this entire system together. You can literally think of an IAM policy as the bouncer standing at the door of your resource. It's got a list, right? And each line on that list is called a binding. A binding just says, this person or this group gets this role. It's the official rulebook for who gets in and what they're allowed to do once they're inside. Okay, but this is where it goes from just being a rulebook to having a real superpower. We can move beyond these simple static rules and create smart policies that grant access based on the context of the request. It's like giving your security policies a brain. And this is a game changer for DevOps, right? Imagine this. You need to give a developer troubleshooting access to production, but only for the next 4 hours. With a condition? That's easy. The access just automatically expires. Or maybe you want to say, sure, you can be an admin, but only on the stuff we've tagged as dev, not prod. It's incredibly powerful security that adapts to the situation. Okay, let's shift gears now to what is, without a doubt, one of the most critical IAM topics, especially if you're doing any kind of automation or DevOps on Google Cloud. We're talking about service accounts. This is the identity for your code, for your machines. So what is a service account? Just think of it like an ID card for your application, or your virtual machine, or some automated script. It's for a robot, not a person. And since robots don't type passwords, they use something much more secure, a cryptographic key. It's this long, complex secret that lets your apps prove their identity to Google Cloud APIs securely. Now, when we talk about those keys, you got a big choice to make.
Do you manage them yourself, or do you let Google manage them? And look, let me be crystal clear. If your application is running inside Google Cloud, you always let Google handle it. A user-managed key that you download and accidentally leave in a Git repository, well, that's a security incident waiting to happen. It's a really bad day.
But you know what's even better than a well-managed key? No key at all. And that's the magic of impersonation. It's a much safer pattern, where you grant a user the ability to temporarily wear the mask of a powerful service account. They get a short-lived token, they do their work, and then poof, the token expires and their access is gone. It's like a key that self-destructs after one use. So this all leads to a super common question, one you'll definitely see on an exam and in real life. You've got a Kubernetes cluster, maybe it's running dozens of microservices, and each one needs different permissions to different Google Cloud services. How in the world do you manage that securely and at scale?
The answer, the one you absolutely need to know, is workload identity. It is the modern, secure way to solve this exact problem. It's a really clever system that lets you link a Kubernetes service account directly to a Google Cloud service account, giving your pods a secure identity without ever having to mess with key files.
You know, service accounts are so fundamental, they're even used for networking. They are the preferred, more secure way to define your firewall rules. Way better than using simple network tags. But, and this is the part you have to remember, you cannot mix them. A single firewall rule has to use either service accounts or tags, never, ever both.
All right, that was a lot of ground to cover. So let's boil this all down. What are the absolute must-know takeaways for your exam and for your day-to-day work?
Okay, here they are. Number 1, least privilege is the law. Forget the editor role even exists. Number 2, impersonation is always, always better than static keys. 3, if you're using Kubernetes, you're using workload identity. End of story. 4, remember that policies are additive. You can grant more permissions down the hierarchy, but you can't take them away. And finally, number 5, use conditions to add that smart, contextual layer to your security. So there you have it. We've just walked through the entire IAM toolkit. You now have everything you need to build a truly secure environment on Google Cloud, from surgical roles to self-destructing access. The only question left is, how are you going to use these tools to enforce least privilege?
We hope you enjoyed this video. Like and subscribe for more Apex insights.